Archimedes' principle was used to construct a cardboard canoe that could be able to withstand 275 pounds and travel across two lengths of the pool, which is approximately 50 yards. Archimedes' principle is shown to the left. This means that you can measure the volume or the buoyancy of any object, fully or partially submerged in water, by calculating the amount of water that is displaced. Buoyancy is the force exerted by a fluid that opposes the weight of an immersed object. This means that any object immersed in water will have a force pushing on it in the upward direction.
The objective of the lab was to construct a canoe made of only cardboard and duct tape that is able to carry a total mass of 275 pounds or greater for 50 yards.
Okay, so to build this canoe, first buy 12 boxes. Arrange them in a 3x4 rectangle and cover entirely with duct tape. Use approximately 5 rolls of duct tape. Make sure every crack is sealed. Then place in the water gently. Evenly distribute weight between the two pilots to ensure that it does not tip over. Then raise the canoe.
The materials used in this lab were cardboard, duct tape, a stopwatch, and a camera.
The data for the lab was, well, for the distance was 22.85 meters for first lap, then 45.7 meters. For the times, the first half of the first lap, it was 46.25 seconds, then 54.2 seconds, yielding a full time of minute 40:45. For the second lap was 60.6 seconds, then 35.65, and yielding 1:36.25. For the third lap was 48.06 seconds, then 46.12 seconds, yielding a minute 36.65 seconds. And then for both of those, the velocities. The first half of the first was 0.494 meters per second. Then it was 0.423 meters per second. Finally, yielding a total of 0.455 meters per second. For the second was 0.377 the first half, then 0.641 meters per second, yielding 0.475. Then for the third, first half was 0.475, then 0.495, yielding 0.473 meters per second total. For the mass of both occupants, Colin Schwartz was 145 pounds, and Logan was 130 pounds. The boat was roughly 10 pounds with the boxes that we used. And for all the laps, the combined mass was 285 pounds. And finally, the buoyant force was 1,000 pounds of the boat.
The objectives of the experiment were met. The design was inspired by a simple raft with a large surface area with minimal mass so it didn't increase any more weight force as two people laid across it. The materials used were only duct tape and cardboard, and the combined weight of the group members was slightly over 275 pounds. The raft successfully rode 2 laps of the YMCA pool for 3 rounds, which was 50 yards each around, totaling on 150 yards.
With the raft's combined weight of 285 pounds, the first lap was roughly a minute 40. After the boat was dropped in the water once and became somewhat waterlogged, the boat had less drag and it made it take up a minute 36 seconds and a quarter. Following that, the boat had to be repaired, and then in the third lap, the boat took a minute 36 and a 3/4 because of its decreased weight. Now, for the velocity, in the first lap, it took 0.455 meters per second in the first trial. It increased later. When the full raft was waterlogged, it increased to 0.475 meters per second due to the decreased surface area. Finally, when the raft was cut down to size. The third trial yielded a velocity of 0.473 meters per second. This occurred due to the lack of oars and decreased size, proving to be not enough for the 2 occupants to ride in it.
There are many errors the group dealt with while constructing the canoe. One error would be that there were some areas where the tape did not seal tightly. For example, the tape had some fold bubbles, and some parts were not sealed or did not stick correctly. Another error would be that the oars were not made properly. During the first run, one of the oars broke and became flimsy. In the second run, the other oar as well became flimsy and useless. Another error was that, not an error but more of a clutch moment, was that there was a layer of boxes that were soaked. The group took them off to continue the run for the finals. If they had been put on the original part, they wouldn't have gotten as soaked. Another error was that the boxes were not strong enough to hold the 2 people who rowed the boat. The last error was that the sailors rowed a different way each time. The first one was them laying down. In the second run, they kneeled down. In the third run, Colin pulled the boat and Logan pulled it back. Each of these errors had an impact on the group, but were minor setbacks. These errors could effortlessly be prevented. The group did the best they could to prevent these errors from happening.
The end.